Alright, so today we're going to be finding like a formula for the area under a curve for polynomials. Let's start off with the formula y equals x. So what I want to find is this shaded area right here. There's an intuitive proof to prove it, but I first want to do it with the method that we can do for y equals x squared too. So yeah, just ignore it. So let's start with the first method of proving or finding the area under the curve of y equals x. We can think of this y equals x graph as multiple rectangles. If you know calculus, you know what I mean. This is basically an integral. So, however, this is not a perfect representation. If you notice here, the area we calculate would be slightly greater than this triangle right here. So, all right, so y equals x. Now, what's the area of this first rectangle? Well, let's just say this is a distance h, and if x equals h, that means y equals h. That means the area of this tiny rectangle here is just h squared, because the base equals h and the height equals h. Now, what about the area of the second rectangle? Well, I'm going to make it also have a base h, but now look at its position. It's at 2h. So that means if x equals 2h, then y equals 2h. If the base is h and the height is 2h, that means the area is 2h squared. And just for good measure, what about 3h squared? Or just, no, I spoiled it. What about if we're at a position of 3h? That means y equals 3h. But the base, we're keeping the same here, right? And that means this rectangle will have an area of 3h squared. So let me just write it better. Height h. This is the first rectangle. This is the second rectangle. And this is not drawn to scale, but this is the third rectangle. So if we keep on adding them, we have h squared plus 2h squared plus 3h squared, and first I need to find something else too. So we have this graph. We're making many rectangles, and they all have a base h. Let's make the final, like we want our area to stop. We don't want to go infinitely long. We want the area to stop somewhere. So let's say it stops at a position of z. That means the final area, or this final rectangle here, would have an area of, we plug in here, y equals z times z, let me think, yeah, just z times h, because it will also have a base of h, but this time it will have a height of z, because we plug in the z, its position value into the y, so we get zh. But look here, z is this distance here, this is z, and this is h, this tiny thing h. That means z divided by h will give us n, or the total amount of terms. Think about that for a while. I'm sure it'll come to you. I don't know how to explain it. So this total value z has multiple h's within it, right? So let's say if h equals 1 and z equals 6 centimeters, h equals 1 centimeters, that means 6 divided by 1 is 6, right? That means there's going to be 6 of these little boxes here. There's going to be 6 bases. Or another example, if z is like 14 cm and h is 2 cm, that means 14 divided by 2, there'd be 7 individual rectangles. So, and I denote how many rectangles there are by 7, n equals 7. So z divided by h equals total amount of rectangles. So look here. So we get the area. Oh, and I also want this h to approach 0. If you've been in calculus, this should be easier for you to understand, but as h goes to 0, as these rectangles approach 0, it will basically look like something like this. As h goes to 0, these pretty much have like no width, and that makes the representation even more accurate. So let's continue on. We can also factor out h squared here. If we factor out h squared here, we get this. Plus z over h dot 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 z over h. And then, well, what does z equal? Well, z just equals z equal nh. That means this is just a equal n squared, or h squared. Damn, I shouldn't have used n, but whatever. 1 plus 2 plus 3. If z equal nh, that means zh times 1 over h, or this thing right here. I mean, wait, z over h equals nh over h. This just simplifies to plus n. So zh just equals n. Sorry for using h's and n, but yeah. And look, this, as we've seen before, this is just the sum of this sum right here. If you know, if you watch my previous video, you'd know what this, or my first video I ever made. This is what it is. And as we proved in my first video, this just equals n squared plus n over 2. Now let's convert z over h equal n. Let's convert n back to z over h's. So here's what we're gonna do. And I'm gonna separate these two fractions here because I can, and it's easier for me to show you. Times this h squared right here, as lim h approaches 0. So now, if we distribute, we get z squared over 2 plus z over 2 times h, and as the limit of h approaches 0, we get that this just equals 0, because basically z over 2 times 0 is 0, but this has no h, so z squared over 2, and we get the area of under the curve of a y equal x squared x graph equals x squared over 2. Because remember, z is our stopping value. Z can also be our x value. So from the integral from 0 to x just equals x squared over 2. And here's the intuitive proof. Y equal x, right? Oh no, sorry, messed up the graph. Y equal x. If at some arbitrary x value you stop here, the height will also be x. And if you know the area of a triangle is 1/2 base times height, the base is x, the height is x, divided by 1/2, we get 1/2 x squared, and that's exactly what we got here for the area using this method of, yeah.